Hello, my name is Fabian. I'm the product manager for power engineering. Welcome to our webinar. Next to me is Mr. Becker.
Yes.
And I have a colleague in Dubai. I hope he can hear me and can.
Hello and good morning or good afternoon to everyone. We are grateful to have you on board for our today webinar, Photovoltaic Skills for Palestine. Thank you for joining us. We hope that we have some nice information for you about photovoltaic training systems. And let me shortly start with a short introduction of our company and what we do. I will share my screen just a second. So can you see my presentation?
Yes.
Yeah. Yes, we do. Okay. Let me shortly introduce our webinar team. I myself, Sebastian Neumann, I'm the Regional Director Middle East. I'm based in Dubai and take care of the Middle East market, including Palestine. Mr. Fabian Schwarz is our Product Manager for Renewable Energy and Power Engineering, Smart Grid and so on. He is in charge of developing and overviewing the production of our training systems. Mr. Manfred Franz Becker is an international expert and TVET expert in the field of renewable energy. Lucas-Nülle company is founded around 50 years ago, and we are dedicated to producing and developing technical training systems for all fields of electrical engineering. We are in the market for many years. We have a high expertise and do business in more than 200 countries all over the world. And one of our strengths is that we reinvest around 50% of our turnover in our R&D department. We have a strong collaboration with German market leaders like Siemens, companies like ABB, BMW, Mercedes, always to develop the latest technologies in our training systems. We are not just a provider for training systems, we call ourselves a turnkey provider for education. Meaning we start and support our clients from the early stages, like we sit together with a curricula, try to see what does the future labs need to bring for the students. We plan the training systems, we develop the teachware, we can help you adapting the curricula according to latest developments and so on. All our products are produced and developed in Germany, meaning we have a high standard in our quality and to give a warranty of 2 years to our clients. Even after those 2 years, together with our local agents in all the countries, we make sure that our laboratories are always running and our clients have no problems operating them. I myself, as I said, I'm based in Dubai, in our office in Dubai. There are 2 more offices, one in the US and one in China, so that we can cover all the entire world with our support and after-sales service. Our training systems are suitable for vocational educational institutions, industrial training centers, universities, and also for army technical colleges. And in Palestine, we have a local office, which is represented by our partner company, Amotech. So this company is taking over all the installation and commissioning of our equipment. They do the after-sales service and they manage our warranty, which is standard 2 years. But as I mentioned earlier, even after those 2 years, we always make sure that our clients are happy and the laboratories are running smoothly. One big part of our company is the Lucas-Nülle Academy, which has actually for you as a client the most important part. This academy is in charge for all the train-the-trainer seminars, which can be either in Germany, nowadays via webinars in times of Corona, or they send their specialists, their trainers to the country to do directly with our customers for on the site, train-the-trainer seminars and helps them to operate our laboratories. They customize webinars for our clients, not just for the training systems. If there's a new technology in the market, they always keep our clients up to date with latest developments. As well, what they do, they develop teachware and training concepts which adapt to all the international curricula. So now let's go into the training systems for our photovoltaic systems. There are, let's say, three different systems. The basic systems, which teach the fundamentals, is called the Unitrain I system, which Mr. Becker will introduce shortly to you. And then we have different training solutions, industry level training solutions, up to practical applications as students need to operate in the field later on. So now I give the work to our two experts in Germany from our Lucas-Nülle Academy, and I hope you enjoy the seminar about photovoltaic systems.
Yes, Sebastian, thank you so much.
Thank you.
Salam alaikum to my friends in Palestine. My name is Manfred Becker. Let me give you a short introduction. What I'm doing, I'm an international expert for renewable energies. I have experience now for over 10 years in different African countries. This is Uganda and Malawi, and some of you might know me from my appearances in Palestine. I've been there for 4 times now and did 3 trainings. One was in Ramallah and in other VTCs. So I know a bit about Palestine and the Palestine market and the Palestine situation. And actually why I'm here is while we are visiting some universities, I detected that they had some Lucas-Nülle hardware over there, and they asked the trainers and the teachers and the students, why don't you use the Lucas-Nülle systems here? And yeah, there come some different answers, and my idea was to reanimate Lucas-Nülle in Palestine and to give you the opportunity to look behind the scenes what Lucas-Nülle can offer in nowadays at COVID-19 situations. So we came up with the idea, and now we are here, Fabian and me, to present some of the hardware and the idea, the philosophy, let me say philosophy, yeah. What is behind the training. Maybe you add something, Fabian.
Yeah, I started before. I'm the product manager for power engineering. I'm in the research department and take care about the products. I develop new one and also give the support. Before Corona, I traveled a lot in the US, Saudi Arabia, Africa too, to train the teachers, to train the trainer. Yeah. And yeah, we had a lot of experience in that. And yeah, so yeah. I think we should start.
Yeah, nice history. Yeah. So yeah. Even me, I did train the trainers, and from this side, I know how important it is to have a real good support. And let me give you the compliment that every time I have a problem, I can call you. You are there. I can pick you and grab you.
And not only you, every customer can write an email, call, and we react very fast to solve the problems.
Okay, let's go into action.
Okay.
Okay, I go over. So it's my opportunity and my task to present the so-called Unitrain. So why is it called Unitrain? And I will tell you what I like about this thing. The thing is called Unitrain because it can train universal fields or different fields of electrical, electronics, engineering, motor, automotive, high frequency, and so on. How is it possible? It's very simple. It's a modular system. So we see this is the basic system. It's the I/O interface, which is connected via USB with the computer. So it's coming, of course, with the software. And this I/O interface offers me a lot of opportunities. You will see it when I go into action. We have measurement instruments inside, amp meters, voltmeters. We have XY plotters. We have oscilloscope, and so on and so on. That means you save the money instead of buying different multimeters and so on, and use this modern, let me say, feature, this modern I/O interface to measure things out. So this is called experimenter. So we have a multi-pin plug here on this side. So I can add it on. At the moment, the EPH1, this is a basic solar system, is connected hardware, as a hardware here on this side. I can even plug it in and out. But before we come to this, I will show you how the experimenter is working. So we have this, sliding in space where I can put in some experiments very simply. Let me see, like this, and I plug it in. And now I can do this experiments about motors and so on. We have DC technology, AC technology, all the basic stuffs which are very important for students when they begin with the studies. So this is called the experimenter. Of course, it cannot replace the work out in the field. This is very obviously, but the main thing is that we start with the basics about solar, for instance. We can do experiments and they can transfer it if they want to maintenance or even to establish a solar plant. So you just add it on as a need for the scientific side or research side of the solar system. So let me share my screen and we can start with some small experiments that you see how the system is working. So let me share my screen with you. That one, now you should see my course. And yeah, you see the course is just in books, software books. And I open, it's power engineering. I have training objectives here. I have the hardware presented. What is it? How is it being used? We have exercises. We have security hints, how to handle it, and so on and so on. So let me see what we can do with it. We can do experiments, and I start with a very simple experiment. It's called recording an open circuit voltage. So let me make some space over here. I'll make this smaller. So as you see my screen, I have a play bar here. And when you're using Lucas-Nülle hardware, it's always the same. You can press a play button and it will show you in steps how to wire it. So this is a very simple experiment. I only need to have 2 wires because I want to check on generator or PV module number 1, which is basically down here. Okay, I make a connection. It's telling me to connect, while we are measuring voltage, to connect a voltmeter. Let me do it the right way. So I need to close this gap here. This is a small bridge, a jumper. It's coming, of course, with the hardware. And I go back to my voltmeter. So the experiment can start. So align the radiator so that the light impinges perpendicular on the PV cell. That means I can mechanically move my sun, my virtual sun, but it's now perpendicular and I fixed it, okay? So now I present a virtual instrument. That means it comes with the software. It's on board, instruments, and I see the XY plotter. It wants the XY plotter. There we have the XY plotter. So it's good to have another screen. So you can bring this while splitting the screen to the other screen, but now we have one screen. I can handle that. So we need to make some properties because the experiment wants to do us some settings. So we have the x-axis, we want the irradiation. Let's check. X-axis, irradiation. And on the y, we want to have the voltage. Okay. So we come up with the properties because we need to do some scaling. So the scaling for the voltage should be 4 volts. Let me bring it in, 4 volts. And the division should be done in 0.5. And we need to do the scaling from the irradiance. 1,300 watts per square meter, 3. And the division should be 100. 100, okay. I press OK. Now we are ready to do what? Yeah, to do a recording. That means the XY plotter. I think you all know what an XY plotter is. We need to record how this generator 1, solar or module 1, behaves when we bring in radiation. What does the voltage, or how does the voltage behave? How is the voltage curve? So what do they say? Set the radiator irradiance to its maximum value. Okay. We have a dimmer here in the back. Start the XY plotter by activating the record button. Here you see the record button. So let me see if we can record our curve. It's coming there. Oh, you see, recording, 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 recording. So it's not the nicest recording I've ever did, but this is how it works. So what can I do? This is empty. If you start the software and the course is not done, this picture is empty. I can drag and drop it to here. Copy and this one, yeah, button. And now the recording is there, and the student has done his recording, something like that. So a nice thing about it, it's a, let me say, it's a self-learning system. All the software is able for self-learning. That means it's coming up with some questions. Now the solutions are already in there. I'm sorry for that. But let's make some trouble in here and put in the some wrong solutions. So let's say this is 6 volts. So the student can check the answers. So you see, if the answers are not right, the participant, the student, the trainee can revise and have another trial for this one. Yeah. So okay, I don't know. Are there any questions? Not yet. Okay, then we do. Let me say another experiment. Maybe we do an experiment of short circuit current. What about that? Let's see. Before I do the experiment, I want to mention that, of course, before you do the experiments, you have the theoretical part of the whole course. What is it all about? What is the ISC, the short circuit current? So you see there is a theoretical part, and then you go into the practical ones. That means the student is not standing alone. He gets, of course, the information before doing the experiments. It would be not possible the other way around. So let's do another experiment for short circuit current. So we have a different wiring. I press the play bar. So we go for amp meter. I think it's here. And okay. So this one should be down here. This one should be up here. So I need to have another bridge. Is it? Okay, short circuit current. Align the radiator so that light impinges perpendicularly on PV cell. So again, I need to open up the recorder, the XY recorder. It's over here, XY. So this time we have to make another setting, or it's the same setting? No, it's the same setting, okay. X-axis, we will have irradiance. Y-axis, we have Now current, it's over there, so we have to make the properties, the scaling. For current, the scaling would be 60 milliamps as a maximum. And 5 milliamps as a minimum. And for irradiation, irradiance, we put 1,300, and oh, this is too much. And we put in 100. Up, you go. So the setting is done. So let's check. Set the irradiance to X maximum. I did. Start the XY plotter by activating the record button. Slowly decrease the irradiance using the dimmer. So let's see what the recording is all about. I will decrease slowly. So the recording is done. I press stop. And of course, I can bring in this one over here. Yes. So if there are no questions, I would stop at this point because this is, let me say, the introduction to the first system. It's called Unitrain. I like it very much because it's high variable. It's portable. It's coming with a suitcase, and yeah, you can transport it easily, and you have a high variation of experiments. Fabian, do you know how many experiments available for?
A lot. Yeah, but let me add something. Okay?
Yeah, of course.
The first idea of a Unitrain, maybe I will remove it here so you can better see it. So the interface itself, I will remove the cables. So this is the interface itself. I don't know if it's come clear at the beginning. It was designed to do basic experiments, to give basic knowledge, and to add different areas to the lab. So the idea was to have one lab for basic knowledge. And in the morning, you can do power engineering. In the afternoon, you are doing hydraulics. We have hydraulics here next to the system, or automotive. So the lab can be full all over the day with different experiments. That was the idea. Now, in time of Corona, it's have a nice feature too. That's what you say. It's small, it's flexible, so you can take it home or give it to students to bring it home to do some experiments there. Yeah, we have a lot of basic experiments, machines, PV.
Yeah. And it's even a state of art. I saw that you have a LED panel for in there, or LED experimenter. I appreciate very much. It's very nice.
So, yeah.
So if we are done with that, we move over?
Okay. If there are no questions to the system, or yeah, I don't know if you need additional questions, additional things to know about the system.
One question: are there any prerequisites that students need to complete before they can enroll for this training?
No. So if with the course, you have the theory inside with experiments. And if you have done once one of our training system, the knowledge with the software and so on, you can take over to other experiments too. We will see it later. If we do advanced experiments, it's the same way of the software and how it's made. So if you want to understand, or the students want to understand the concept, he can do everything of our training systems.
Yes. And let me add something. So there is another administrative software. It's called the Classroom Manager, which is of course interesting for the trainers, for the teachers, and to manage and to record the students, how many courses they did, how they were performing and so on. But this is not the part for today. We are only looking at the technical part. But this tool I like very much as well.
Yeah, we have also solutions for labs to control and monitor. And also with the Classroom Manager, you have a possibility to modify our courses and bring your own things in the courses. Yeah, maybe one part of the course is a little bit too short for your needs. You can extend it. You can add something.
And even you can involve it in your curriculum. So yeah, it's sometimes it's not easy to bring it in as an addition to the curriculum. So to the curriculum which is already there. So you can take the parts you need, you bring it in, and you edit. So it's very easy.
There are other companies, they like our LabSoft, it's called, the software, and the Classroom Manager so much. They only bought this part of software without equipment and add their own, their own education inside
content,
that. Their own content.
Interesting.
Yeah. Okay.
So we can move over, Bella. Are you ready? So you follow us to.
I guess we take the other camera.
Yeah.
So. Okay.
So now we are here.
Fault finding. Oh, good question.
Yeah.
This camera? Okay. Yes, of course. There are chapters in the course. If you open the chapter inside the Unity interface, we add faults. And like at the electrical machine, we have a phase fault, and the student have to find the fault by measuring. So yes, we can do fault finding too. And I don't know if you said it before, the Unitrain have a low voltage system. And so everything what you're doing doesn't harm the student or the equipment. So you can put a short circuit somewhere and nothing will happen. You cannot destroy the systems. The bigger system we will look next have higher voltages.
Okay.
And it can be dangerous. So you need some basic knowledge what you are doing, because not everything you can protect. It's not possible.
Sure.
Okay.
Yes. So I don't know. I'm in the camera right now. Okay.
You started with screen sharing. That's why you don't.
Okay. Sorry. I just wanted to add a small thing because now the questions arise, and this is good. Just don't mind to ask the thing. The students can even have a printout of the whole course. It's possible, yes, as a PDF. So you can even share it for home learning. Okay. So we go over to this stand. The course is called EPH1.
Maybe you stop the screen sharing so they can see the devices. Not everyone knows. Just stop it.
Okay, I can stop it here. Just okay. So we are now here with a, let me say, movable stand. It's just the same. All are modules which are clicked into the stand. This is the mechanical part. So you can order this stand which fits to your need. So what do we have here? We have a power supply. We have a Siemens Centron. This is a multi-instrument. We have a single phase inverter. We have a solar simulation module, 3 solar modules. So we have a standard sticker charge controller. We have a small inverter. We have some loads over here. Of course, we have a battery. We have a variable resistor to bring it into the solar module to see how the modules behave, to make recording, maybe MPP and so on. And of course, we have another measurement instruments. So I like this thing very much because you can show a lot of things, and yeah, let's go into action. Why not?
And what you can see is that we are using industrial devices. So this is from Siemens, this is another manufacturer. Of course, we have some devices like this emulation here that's made from us. It's not an industrial device itself. Yeah, we try to use so many industrial devices and different manufacturers. Okay, here we have a lot of Steker, but this inverter is an other manufacturer. Yeah, that the students learn about different manufacturers in the field later, so they get in touch with the equipment.
Sure. Okay, and be ensured they're all handmade. In the back, there are the ladies and gentlemen, they are soldering, and yeah, they're bringing together the hardware. That's very important. So the APH2 is then, let me say, the logical step number 2. After you have used the unit train, it's for the further educational use, or for, let me say, the more experienced students. So let's do some small experiments over here. Let me see what we can do. Yeah, I want to do experiment of shading. So let me start from the beginning. It's the same. You have the paper, and it shows you how to wire it. Oh, I already go to the end. So this is what they want to do. And you see you have these modular bridges over here. You can easily use. So let's see what they want us to do. They want us to have 3 modules in series. So I do simply a series connection. It's done very quickly. Okay. I remove this once. So I bring in the variable load. I pick it from this point. Here we go to the input of the resistor. So from the output of the resistor, we just bring it to the I input to measure the current. So, oh, this is wrong. We're coming from here. So from here we go over there, and then of course to pick the voltage. Let's take that one. We go over here. So this is a multi-device. I can simply press U, and it has a voltmeter, I, and maybe the wattage. So let's see how the experiment is working out. So turn on the analog digital multimeter and select the voltage current display. So they want us to have current and voltage. So I remove the power. That's it, very simple. Set the 3 solar module simulations to irradiance of 1000. So here, with this potentiometer, I can decrease, increase very simply. But I do, as they say, 3 modules 1000. Set the potentiometer to about 50 ohms. It's here. And leave it at the value during the measurement in this experiment. So, there is the irradiance on one of them while observing analog digital multimeter voltage, current and display, as well as analog display on the solar module replicas. Okay, I switch on and let's see. So the meter is showing us 8.9 volt and 1.41 amps. So what they want, vary the irradiance on one of the solar modules. I take this one and let's see what's happened. I put this to 200. This might be caused by shading or something else, as you know. So we can see what happens with the voltage and of course with the current. So it drops. This is a very simple experiment to make it clear what happens if, if a module in a string is failing or shading or covered with dust. I know in Palestine, we always have this big dusty dust problem. You see what the loss is. Okay, when we have done the experiment, so this is now challenging us, Fabian. What happens when one of the solar module reflectors is shaded? The current rises. Oh no, the solar module's voltage becomes negative. No, I can't detect. The current and voltage remain unchanged. No. The current drops to a low value. Let's check. The answer is partly correct, but there are still other possibilities.
Do you know it?
I don't know. The current rises. The solar module's voltage becomes negative. Let's try out.
Sure.
Sure. This is how you can check your answers yourself, the self-learning effect. So we can make the readings right here. And you see the chapters of the books sometimes are bigger, sometimes are smaller. You need more time. Fabian, is there any hint about how long the course will take?
Yes, on our website, for every course, we have a suggestion how long it takes. It's around 8 up to 12 hours.
Okay. Yeah, this might be interesting for planning the
practice, yes.
Yeah, the practice.
The lab and so on.
Okay. So are there any questions to this small experiment? Or I will shift to another experiment.
Maybe if you're waiting some interesting point, why it's become negative is so important. It's called hotspots.
Yes.
In your PV system. Where's the animations? So let us see this one. So if we have a shade of one module, it becomes negative, the voltage, and the voltage will be the voltage of other modules. So if you have a string with 100 of modules, one get, I don't know, 1000 volts and will be burned and your system is damaged.
Yes.
So this is one important point to know about PV systems.
Yes. And you see, the software always gives you, or sometimes gives you some nice animations to play around to make things more in a playable gamification. We call it gamification. Is it like that? Or just give you some more information?
Yes, some difficult things. It's better to have an animation instead of a picture in a book.
Yeah. So here is another animation about the bypass diode. How is the effect of the bypass diode? That it is a very important part in the solar module itself. So
modern solar modules come with that diodes normally, but you have to ensure it's included or not. So you have to pay attention.
Sure. Okay, so I will do another experiment. Let us see.
There was some questions.
Regarding Classroom Manager, there was a question.
Let me see. I have to move a bit to see the questions. There was one question about the Classroom Manager. So is Classroom Manager like a learning management system that tracks students' learning? This software is local. It's run on the computer it's installed. There's also a local server installation possible. And yes, if you have a lab and the server installation, you can track the students, what they have done, what they are learned or not, or there are some missings. If a real LMS is more cloud-based, so we have another solution. It's called Vocational. I don't like to talk about so much about Vocational at the moment. We should focus here, but keep it in mind if you're interested in that. Call the sales.
Yes, don't mind to call Mr. Neumann. It's he can give you the missing information. So I will close my part with a, let me say, a grid parallel connection. Let me see, determining solar power. What can we do? Experiment grid feeding. So we change a bit the arrangement. and we do a complete wiring, as we have a small single-phase inverter here. So the wiring above is done. It is done. So let's see. We don't need a load. We don't need this. We don't need that. So let's clear up the scene. So we are bringing in, we are bringing in the bypass diode. I switch off while I'm wiring. Okay. You see, this is a bypass diode. I bring it in. So add on here, and just a simple experiment. So we are done. Protective earth is there. Okay. Now let's move on. What is the experiment about? Set the irradiance of 1000 for the solar module simulation and turn them on. I will do it. So move the single phase mains connection, main switch to 1. I did it. So we have to remove the L and N because it's indicating that our plug is the wrong way around in the socket. So what is your solution for that?
I don't want to go under the table and move it. So
yes,
just
sometimes we have to make some. Okay, it's okay.
It shouldn't affect something.
No, it should not affect. Yeah. So and wait until the PV inverter has synchronized itself with the grid and supplying maximum power. This can take up to 2 minutes. The power voltage are measured using the power quality meter. So, Dilla, can we show this a bit closer? Is it possible? So, this Siemens Centron is a multimeter. It's a really nice device. I can switch over to different measurements. It's giving me VA, it's giving me the wattage, it's giving me VAR, it's giving me the wattage, already total consumption, frequency, active energy. So the menu is very, very large for all the experiments we can cover. So the voltage, let's see, is 225, and okay, we want the wattage here. So we wait a bit more.
Yeah, but what we can see, the current of the modules, it's increasing slowly.
Yes.
So he started the MPP tracking and tried to feed so much power into the grid that the modules can provide.
Yes.
And this power in the grid, what's fed in the grid, will be increased slowly too.
Slowly too. It's synchronizing and we're picking the maximum. The MPP tracker is working and we try to pick out the maximum as we can. So let's see where we end up. So, by the way, Fabian, what are you going to present us while we are synchronizing?
Yes, you present now the basic with the unit train.
Yeah.
This system is a little bit advanced, but still the basics of PV. And I would like to show you some applications.
Okay.
So
That's
I have
good.
two systems. One is more or less an island solution, and the other one is interesting for distribution. So what's happened in the grid if I add a PV system? How its effect and what we can do to control it.
Yes, I think there is a big demand for this net analysis, because when I was around in Palestine, yeah, they were discussing this. What is the grid code? Is there a unified grid code in Palestine? And if there is, what is it? And sometimes they distribute, or they want a net analysis, impact net analysis of what the solar modules do, or what solar generators do. And no one really knows how to handle it. We can do it with this equipment.
Yeah, we can show how we handle it in Germany or in Europe.
Of course.
What possibilities we have. It's yeah, all possibilities of the devices, and this we can use in the grids there too. So
true.
In the meanwhile, there is one question: is there any experiment about the PV inverter itself and the different components, stages of the inverter, and go deeper to the control algorithm of the inverter?
So for everyone, I don't know if you hear my colleague, is there any sub-experiment about the PV inverter itself and the different components, stages of the inverter, and go deeper to the control algorithm of the inverter? Yes and no. We have some training system for power electronics where we can have a look at different parts of the inverter. And we can change some modulations too. But here we have an industrial device and we are not able to modify the firmware inside. And unfortunately, we can, at the moment, not modify it. So the MPP tracker and so on, we cannot modify. This question comes very often, and it's planned in the next years to have something in this region that you can design and test your own MPP trackers.
Okay.
So
yes, Fabian, I've done with my experiment. So we're ending up feeding into the grid 112 watts. So I brought it on the screen. I tested. My answer was right. So I'm done with the EPH2. Now, thank you so much. We will meet later. So I will hand over to my colleague Fabian to proceed with EPH3.
Okay, there was no more questions, Stella? Okay. So what we saw before are the unit train for the basics. The EPH2 Mr. Becker present is more an island solution. There's in the courses project how calculate a PV system for island solutions. And the last experiment with the PV inverter here was it is only a small part of the course. And it's single phase. If we go to the distribution network in power engineering, we have a three-phase system. So I would like to go to the other system, Dela. So we have to switch the camera. One moment, please. Okay. This big device here is an industrial three-phase inverter, not a single phase. It's much bigger, you can see it. It's connected to this point where we have also other devices connected. So here on the generator side, we have a PV inverter connected. We have also a big battery storage. You can see it on your right side, this one. This is a real battery. It's, so I can open it. It's not an emulation or something, or simulation. Oh, come on.
Let me open and you can talk.
Yeah, there's just the screw I don't want. So, yeah, please hold. You can see here's a huge black real battery. And yeah, in Europe, this is the manufacturer for battery storages. Okay. So it was here. And directly next to it, we have a resistance load that represents our house, our consumers. In the distribution network, from the power plant's distribution network, we come with transformers to the local area, transform it down to our consumers. So if you see the voltage here, we have 380 volts at the moment. And if I adjust the load, one moment.
Manual control.
No, not on the screen. You can see if I'm adjusting the load, we can affect the voltage.
A voltage drop, yeah.
We have a voltage drop to our consumers. This is, yeah, everywhere, yeah, well, in the past, it was designed the network from the generation or the distribution network to our consumers. Now we are adding PV systems. For that, we need to know this is a huge PV inverter that needs up to 3 kilowatts of PV power. We don't have panels in the lab. We need a lot of them, a lot of lamps, and the heat is too much for a lab. So what we are using at the bottom is a DC power supply. That emulate a PV field. Yeah. So I will show it to you on the screen. We need a software. So with this software.
Yeah, it's a controlling software
for this, software
for the solar plant. Yeah.
What we can see here is the characteristic of a real PV module or a PV field.
Yes.
On the right top corner, you can see the field we have. So we have 4 strings with up to 8 modules. We can adjust the irradiance here, or I can modify this PV field. So I can add a shading here. I need to transfer it to the DC power supply. And this DC power supply reacts like, this characteristic, like this real PV field.
Yes, we need to synchronize now. Just
waiting
we need to a minute.
Synchronize. It was a little bit bad. And what you can see there is, how it's called, a marker. And the marker shows us the working point of the inverter. So we can follow the integrated MPP tracker, what he's doing.
Yeah.
Yep. So we need to wait a minute because he disconnected from the grid. Come on.
Yeah, it can last for up to 2 minutes.
Yeah, I reduced the reconnection time.
Okay.
It should be very fast, but let's see.
Oh, it will. So how is Fabian? How is let me say the data connected? I see over there we have the Centron. It's connected via Ethernet. So we have USB connection from the power supply and.
Okay, yeah, good point. We have USB communication from the DC power supply to the computer. And this instrument will automatically find the DC source. And yeah, it can communicate.
And of course, the staker inverter is always also in the network, I see.
Yes,
so,
the staker, I would like to show it a little bit later.
Okay.
So because at the moment, I show it at the devices directly.
Yeah.
But what's more interesting and for the overview and for the understanding is a SCADA system. And in the field, you will find a SCADA somewhere too.
Yeah. I've seen it in Palestine. Yeah, they're working with a SCADA system, of course.
So in the distribution network, to control the breaker, to see your energy flow in the grids, you need a SCADA system. Otherwise. So now you can see the marker is moving. He starts again, like the other one, to feed power to the grid. But here we have a visualization. And the other one, we only have a meter to observe.
Sure.
So, and what's happened to our grid now? If you go back to the meter data, you will see the voltage is increasing a bit. And if I reduce the consumer again, it will increase more. So before we had 380 volts, And if I increase it more and more,
more irradiance, yeah.
more radians, and the MPP is moving, it will increasing too.
Yeah.
So this can be bad. So if you designed your grid so that your consumers are healthy, they have the right frequency, the right voltage, and now you are adding a PV system and the voltage increase more, you can damage other devices
Of course,
in the grid. Or if you have protection, it will trip and you have a blackout. And both cases, yeah, you don't like to have it.
No.
So we have different options. In the back now, I will leave the PV system like it is. We have a SCADA system. We have here a house that's connected to the grid. So the consumer here in my setup are this fridge or a washing machine. Here is the PV inverter. And like you told me before, it's connected via USB to the computer. And I get the internal readings, the measurements. So the voltage, the power, and this is not directly matching to this one because we have losses in the system. Once is the module, and once is what we are feeding to the grid. So efficiency can be interesting too at this point. Go back to my voltage. I can see here now the voltage of my grid over all three phases. The
average voltage,
average.
yeah. Okay.
And this power quality meter is connected via Ethernet to the computer. So here, again, we have different manufacturers, different protocols, different communication interfaces. And we have to bring it here in the SCADA together, and the students can learn, yeah, how I can control, monitor a device too, and how I have to build a network here. So back to our problem, that our voltage is increasing. We have different, let me reduce the shading here. So I get the full power. Hurry, so you don't disconnect again.
Yes.
Let me see how high I can get the voltage, like that. Are you doing something? Let me switch off the battery. Now we can see more effect to the grid.
And you switched off the battery.
The battery,
so,
yes,
okay.
it was parallel connected. I switched it to manual control, but okay. One thing what we can do is to derate the PV inverter. So a provider can add a limitation to your PV system to hold the grid stable. So if I add now 90%, so there's a limitation. Only 10% of its possible power will be fed to the system. And we can see it directly at the solar panel. The MPP point is not at the top one, it's lower, because he cannot provide power to the grid.
And this is part of the grid code in Germany or in Europe?
In Europe, yes. It can be. It depends on the power of a PV system. So if you reach a power and you don't have other devices that limit the grid feeding, they can say
so you can derate.
Derate it. Also, it's possible, like we are doing, over a communication interface. Do it not static, do it dynamics, depending on the voltage of the grid. Okay, let me reduce this one. Also, a possibility is to add a battery storage system. So we are talking here from a house, from a household. In Germany, it's very common to add a battery storage to the house, because we have so many PV that the grid cannot handle it anymore. And now if you add a PV system to your house, you need a battery storage. Otherwise, you
you are generating, but it's for nothing. So
yeah, you get no money for it,
yeah.
and yes.
So it's just the market is just exploding, I think, with a battery, with a battery storage.
So and how it's working now, Taylor? At this point, where all three systems, the generator, the battery, and the consumer are connected to each other, we have measurements, industrial measurement devices here, and they record the consumption and the generation. And with this both values, I can bring the grid side to 0. So in the automatic mode, you can see now, here's the power for the grid, and it's nearly 0, not 100%, but nearly 0, because the battery storage now consume the rest and store it to the battery for later usage. Over the day, you are not at home, you are working somewhere, you are not consuming power, but you have a lot of sun. And in the evening, you are using your battery to feed all your consumers, your TV, your fridge, cooking, and so on, to shift the power consuming. It's a kind of energy management. Yes. So I was talking so much. Were any questions so far? I hope it's interesting. No questions? Okay.
So we proceed.
Okay. So the battery storage is now in the manual mode, but here also we have a communication at the top and can control it. And one interesting point is to provide reserve, it's called. So if we have not enough generation, we can say the system, here the total household with all these subsystems, please provide, no, not so many, power to the grid. It takes some time. Maybe it's not working at the moment because we have so many PV.
No, it's providing, yeah.
It's now, so there are situations where it's not possible. So this is a wish from the provider. Please take power or give me power so I can stabilize the grid. So this is the wrong direction because we have under voltage. So if I choose, please provide power. So I'm feeding now power to the grid and can stabilize my voltage to 400 volt. So we saw now two possibilities of regulate the voltage.
Yes, stabilizing the voltage, yeah.
Once was the derating of a PV system or adding a battery storage.
So there is a question from Mr. Elias. Could we define a load profile and study the system performance under different load profile scenarios? I would say yes.
Yes, a good point I missed. In the solar panel software, there is a possibility to add a solar profile. If you don't have one, you can
load.
Yeah, you can load, or you can design your own characteristics. So like normally we have 24 hours. So I say 24 minutes are my 24 hours. Somewhere in the noon, I have the
peak,
maximum, the peak. And I can do something like that.
Nice profile, Fabio. You are really an artist.
Or in the courses, you will find network transformer here. Not assembly. Let me see.
Yeah, you can find the profile in
you
different tasks. Yeah.
In some tasks, you will find.
I don't know.
Of course, of the day. Yes. also pictures, and here should be
Was
a
the
profile.
solar profile, yeah.
So let's save it fast. So this is a given profile from us.
From an experiment, yeah.
From an experiment.
This one.
No. So this is normally how it's looked like with the shading in the afternoon. But if you have a own characteristic, you can add it too.
Yeah.
Just right-click, import from clipboard. Okay.
Yes.
More questions? No. The last possibility from the distribution or from the provider is to add, Dela? To add a special transformer to the grid. It's called a variable auto transformer. So I can adjust with the motor here the voltage and can bring the voltage at my consumers to the right level.
Yeah.
So
Yeah, this transformer is normally it's scatter controlled as well.
yes,
You can have it. Yeah.
we can control it here automatically. It's not prepared for this presentation, but it's possible.
Yeah. Okay.
Okay.
Were there no questions? I think we move over.
Okay. The last one. No questions. In this setup, there are two stands, so it's very modular, and this is one experiment. So for different experiments, you have to arrange the setup new, and yes. So
yeah, what I like about this this situation is that we are now really up to date. We have the battery storage, which is even very interesting for Palestine as well, because the power situation there is a bit critical. Out of other reasons, we cannot. Yeah, this is we have to state, and this is why the battery power is more and more important even. And here you can simulate what the Palestinian providers want. What is the impact of the battery, and what is the impact of the solar grid or the solar field, solar plant to the grid, because this is all about the voltage. What happens to the voltage? This is, I think, they want to see.
Yeah, there are also possibilities. So we have a lot of these small modules, and you can add an overhead line, you can add additional protection, and can verify maybe, yes, you have an idea how it can work. This is a little bit part of research, but you can use it here too with this equipment.
Okay.
Okay, go to the last application I prepared. This is a bit different, or it's have a different target.
Let me go here.
Target here. Yeah. So yeah, can you move a bit closer? This is now a PV system again, but it's a single phase, and the focus is different. So the focus here is on a household, not on a distribution network. If we have an unstable grid, and I have some critical consumers, or I would like to have a cold beer in the evening, without fridge it's a bit difficult. So
that means we are dealing with under voltage,
blackouts, over voltage, frequency problems, and so on.
Okay.
Again, we have here on the left side our grid, a measuring device, a circuit breaker that emulates here a grid fault. So maybe on the power plant is everything fine, but on the way to me, it's a blackout or
it's tripped, it's switched off.
Yes. Yeah. Here we have a special PV inverter. It's an inverter and a charger. So it's include more or less both system you present in the EPH2. On the right side, we have a single phase AC consumer, but also a connection for a battery. So here we are going to a bigger battery on the bottom. The battery, please. So we have a huge battery here.
And again, we have the power supply.
Yes, and again, we have a PV connection here. That's represented by this DC power supply we saw before.
Yes.
This one. So we have different suppliers here. We have one for battery, PV, and the AC. Yeah, you can see on the right the lamp. If I have now a disconnection here, maybe you could saw it. There's a small flickering.
It was the switching over point from grid to battery.
To battery,
or
yes.
to solar, yeah.
So we have a UPS function here. So if you don't have a stable grid, this can be a solution to supply your consumers.
This stacker inverter charger, do we call it a hybrid inverter charger?
Yeah, we have different
sources.
Not many spellings for this system. We call it hybrid inverter because hybrid, we have different sources. They are supply my consumers. But you can talk here too from the microgrid. Okay. I will.
So we have a question, Fabian.
You have a question?
Can I come up? Mr. Elias, he's very interested. I like it very much. Is there an experiment that have the whole power system components, classic and modern structure, and is there a coordination ability by them with the SCADA system? Yeah.
Yes, we have. Let this camera or take this one. So in your back, in the background, let's take this camera. So you can, not all, but the most systems you can add to each other and have a whole grid, a smart grid or microgrid, or grid emulation, what you want. So this system are standalone solutions for training. And if you trained your students to be experts, you can add all the system together and control it via SCADA or, yes. So we have synchronous machines, PV, I showed you 3-phase. Wind is not so interesting for you, I hear it. But let me say something more to the synchronous machine. It can be a diesel engine, coal, nuclear, water, whatever you want, we can emulate. So yes, we can build grids with the training systems.
And control.
And control it, yes. Yes, can you go to this screen? No, it's touch screen here. So there are also training systems or courses for microgrid, it's called, where we have a bus system for distribution. We have here a higher distribution network, electrical car, consumers like industrial, they are producing something, a wind park, hydro, PV, and we can monitor and control it remotely.
Energy mix production. Yes. Okay. So I think we should go back over here.
So the 3-phase system are able to connect to the other one. The other systems are more basic, and sure you can add it, but it's not very, it's a bit complicated because normally the distribution is 3-phase, and here we are talking from a single-phase system. Yeah. You can add it, but you get more trouble in the grid. It's just single-phase, and you get an asymmetric grid. It's not so good. But if it fits to your needs, sure, you can do it. Where I stopped here. So one, we have a UPS function. I would like to share the screen. Is there another question? I see it here at the top.
Yes.
Okay.
No, that's the question you already answered.
I answered, okay. Again, we have this solar panel emulator with a DC power supply. Maybe you can see it, we have less modules here because it's it don't have so much power like the other system. We don't need it here. In the back, you have our SCADA again. Let me make it a bit bigger. And you can see we have the grid here. If I make
If you
the grid
switch on,
connection,
if you re-switch, yeah.
yes, I can see we have a bypass that's going directly to the consumers.
Mm-hmm.
Here is the internal setup of the system, and we can see different parameters. At the bottom, the connection to the battery, and on the other side, the PV. So if you don't have a grid, we can see the power comes from the battery, and if there is PV, or then comes also from the PV system. So if I reduce now, well, I switch it off, we have night. I will see now here from the battery current, it comes from the...
It's battery feeded.
Yeah, it's battery feeded now.
Yeah, good.
Here we have different possibilities too. This is now set up as a UPS, but I can also design it via the parameters that we, how it's called, that we are more using PV and the battery for our own consumers, like the battery system before.
Okay.
So it's not focused on the UPS, it's more self-consumption optimized system.
Self-consumption. Yeah, this is, in Germany, it's a very, very interesting self-consumption. So we want to have a high level of self-consumption.
Yes. So you have with this system different options, with grid, without grid, UPS function, and self-consumption.
So there is another question, Fabian. So the switch between the grid and battery, it's seamless with no intervention needed from the consumer.
No, yes, the switch here is just for switching a grid fault. So, to answer the question? Yes. So in the setup directly, it's not so clear, but here I marked arrow and called it blackout
or
and
tripping.
It's a tripping. Yes, it's somewhere on the way to my house, to my system.
A fault.
A fault. Yes. What you can see at the bottom, we can add more systems here too. Here you see a water pump we added here. And this water pump can be used for farmers to feeding fields with water for the plants.
Yeah, this is...
in Africa, it can be a solution for drinking water. So you pump it from the ground to storages. And this system is connected via DC directly to the battery.
Okay. So I see over there, yeah, the wiring.
So directly from the battery, it goes to the pump. There are two operation modes. One is battery mode, we are set up now, or directly with a PV module. But here it's very nice because you have different needs. You have one AC, what you need, and maybe water. So it's on the system, and it's just say that our external storage tank is full.
Okay.
Can you move the camera? Yes. So here we have a motor driver that's fed by DC, converted to AC, and run the pump. The pump is here a real pump. a real pump. In this nice storage, there's water inside.
Mhm.
And if I say
We have the sensors for
sure, we have
for
sensors.
levels. Okay.
Also for pressure, we have sensors. We can measure it with a power meter.
And as I see, it's a three-phase pump then at the moment. Yeah.
Yeah, it's a three-phase powered
Okay.
pump. It's how it's called, a permanent motor.
Okay.
Yes. So if I say my tank is not full, it will start pumping and will drain the battery. So if we go back to the SCADA, you can now see it takes 60 watts from my battery.
Yeah.
And if I have no
Solar feed?
solar at the moment, yes, I have to choose what need is bigger. It's my water bigger or my AC consumers. So I can define different cut-off voltages to control, manage the system.
Yeah. Otherwise, you will drown the battery. This is not good. So,
Yes, too much.
Yeah.
Okay. This is very new, this system. We have it since this year. So that's why I cannot show a course at the moment because it's not ready. But I'm working hard on it.
You're working hard on the software. That's
on
good,
the software. So I'm the developer of the system.
Yeah,
so,
that's good. So I think, Della, if there are no real questions, we like to thank you very much for your attention. We like to thank Della in the background for organizing everything. I like to thank Fabian, my colleague.
I guess Sebastian would like to say something more. If you see questions,
thank you for you guys for presenting from our showroom in Germany, and on all the participants for joining us today. Tomorrow I will send to all of you a short overview and a small presentation that you get an idea what was presented today, as well as my contact details and the contact details from our office in Palestine, so that you can always come back to us if there are any further questions or you need some more information about different systems. We are always happy to welcome you, to answer your questions and to be there for you. And hopefully COVID times will change soon, that we can be in Palestine ourselves and don't have to do webinars anymore. We all would like to visit you again and all our other clients. Thank you all together. I wish you all the best and stay healthy and safe and have a nice day.
Yeah,
Bye-bye.
If there are more questions, I will stay some minutes here in the back and type your questions and we will answer it.
For sure. We are around.
We also will send a recording around, which was just a question tomorrow. It will be uploaded on YouTube, and I will send you as well the links that you can directly access the webinar again. Okay, all the best. Take care.
Take care.